Right, welcome back. We've got a Harvard H407 here today. This has come through from one of my viewers, and he mentioned when he sent it through that the mains / DC switch on the back had fallen off and was broken, which he wants me to look at, and basically hopefully just be in for a normal tune-up. This is one with the black speaker grill on the front. It's a little bit dented, and I'll check that the speaker's okay in there, as it looks like it's had a little bit of abuse. And he sent it through with an original Binatone 5-star coffin mic here, so we'll give that a little clean up and a squirt of foam and get that looking better. So let's just see what it's doing. We just need to look at that switch first before we power it on, just to make sure we don't cause any problems, and we'll look at the power supply as well on it as well. I quite like these little sets. I've done one of these before on the channel. We had to do a fair bit of work to get it going, but let's just see what we've got to do with this one. And safety first, just a quick check of the plug just to make sure the connections are good. We've got a 5 amp fuse in there, which is a little bit higher than I would like. Normally with these sets I would like to see a 3 amp fuse in there, so I may well change that. And it is one with the shrouded pins as well, so if you ever get mains operated equipment in, it's always worth checking the plug, checking the fuse, and also checking the condition of the lead as well. You don't want to be giving a customer back a radio where there are mains issues on the lead, so it's always worth checking that out and rectifying them. Right, so the mains or DC switch here is broken, and the customer did mention this to me. We would need to order a switch and also a capacitor to replace that mains capacitor. We'll test it anyway. It might be okay, but I wouldn't be happy running this off the mains side without replacing that capacitor and those capacitors on the power supply board, because they probably have gone or certainly on their way out. I imagine that these boards aren't known for capacitor problems on the main board. This is essentially the same board as what you'll find in a Amstrad 901, of course. So you won't have that issue on the main board, and they look to be the same brand of capacitors. So I'll have to see what we can do on that switch front. I may have something in stock here, possibly. I haven't got a huge amount of switches here, but we'll have a little look, see what we can do. Right, so we're just running power straight into the radio via the other side of the switch there, and we've turned it on, and we've got on channel 19 we've got our squelch reduced. A bit of a noise on that. I don't know how good or bad this is yet, so let's do a couple of tests. First we'll just try keying up and see what kind of power we're doing. I'll put on channel 20. Okay, so we might be in low power mode on this, so there's a low power on the back, so we'll pop that in, and we were indeed. So it's doing 5 watts. We've got our S meter there, we're doing 5 watts. There we go. And let's see how on frequency that is. There we go, that's absolutely on frequency. Looks a bit wide. We'll check that on the deviation meter in a minute. That looks to be oh yeah, that looks a little bit broad. We'll check that and deal with that. We'll just see what it sounds like on the President Randy first. 1 2 1 2 1 2. That sounded okay on there. No buzzing or humming. We're right next to the set on full power, so that's good. This will make you laugh. Almost off the scale on the deviation meter there. I have to wind that in. So we're on frequency. We're transmitting on about 7 channels at once. Let's see what receive is doing. Right, that's 1 microvolt. That sounds absolutely dreadful on receive. Definitely need to do something about that. Can you hear that? That's not good. But nonetheless, it is doing 1 microvolt for 12 dB Cyanide at that, even though that sounds absolutely awful. Let's drop it down. I'll take it up again. Yeah, 1.07 microvolts for 12 dB Cyanide, but that sounds absolutely ghastly. Well, it is sounding a lot better at 100 microvolts. I won't. I'll just turn the volume down a little bit. It's a little bit loud. We'll switch it on. There we go. So it is better with 100 microvolt signal, but on the low end it's not good. So we'll look at that when we tune up. Right, okay, so let's get started. First off, let's just check the VCO. Right, looking at that point down there, which is the junction of C9 and those two resistors. We're on channel 1 and we're on receive, and we should have 2 volts, and we've got 0.85, so we need to bring that up to 2 volts. And we do that by adjusting T1, which is that can there where my finger is. So we've got 2 volts on receive, but on transmit we're getting a minus voltage, so we need to adjust CT1, the trimmer CT1 there, that red trimmer just there, you can see in shot, and so we get that at 2 volts when we're transmitting. There we go, 2 volts on transmit and just over 2 on receive. The radio is already doing a full 4 watts, so we'll go through the power section, just try and just peak it, and that's using T2, T3 and T4 here. And then we've also got two inductors there, one behind there, one behind the resistor, which is our full alignment there. We'll go through that and we'll try and peak it, but I suspect it's actually already at peak. And it's always, sometimes if you're not overly concerned, particularly on older sets, if you've got cores that look like they're a little bit damaged and you're already happy the radio is producing the power, I really wouldn't mess with them, because you can cause more damage. But it's also worth noting that if the radio is a radio where there is any kind of filtering on the output which might affect the harmonics, and you've got a spectrum analyzer, then it's very definitely worth investing the time, because you obviously don't want these radios to be transmitting on frequencies that they shouldn't be. There we go, we got that nice and evenly matched. We're just a tad over 4 watts there on my meter. We're on channel 40. Click it to channel 1 and we're exactly the same. We'll move up to channel 20. There we go, exactly the same. That's what you want. You want a nice even spread of power across the board there. So we're nicely optimized for power wise, and it's nice to see the meter actually working. Although it does probably need a bit of adjustment, but that's nice to see the meter working properly. Right, you can see the signal meter is faded. There should be a red section on the meter. It's either faded or it's been replaced. But when we TX, we need to get the needle roughly in between where the strawberry patch should be, which is about, if you look at the top rail where you got your signal 9, you're looking at about 11, so the 2 digits after the 9, that's roughly where it should be. And to do that, we adjust that little trimmer there right by the resistor, the ballast resistor, which was fitted because these radios were originally supposed to be more powerful than they were originally allowed to be. There's an interesting story behind that, but I'll leave that for another day. Right, that's about right now. It is a little bit sticky, the meter there. I'm not actually, let's try turning it off and see what happens. Obviously the on-off switch doesn't work. We're running off of the lead at the back, aren't we? So let's turn that off. Okay, so it is dropping to 0. I just wanted to check that. Right, okay, that's fine then. So deviation is adjusted via that trimmer there, just above the red trimmer, and this was very high and it's now spot on. 1 2 1 2 1 2. There we go. 1 2 1 2 1 2. Just a quick check on the Randy, and that's fine. I'm just swapped over to the customer's mic. Going to give that a little service inside before I send that back to him and clean this lead up. Well, before we do receive, I always peak the FM detector, which is that can there, and we've got that to the maximum output now that we can on the oscilloscope. I was doing 0.83 of a microvolt for 12 dB SINAD. It's still sounding a bit lousy. That is sometimes just how the radio is on a low signal. That can just be a characteristic of the set. So we might be able to improve that. We might not be. But we're going to go through the front end on this, and then I'll come back and see if we've improved on it. Wow, massive difference there. Look, 0.29 of a microvolt, and it's sounding so much better with 12 dB SINAD. So the front end of this had been absolutely butchered by somebody. Somebody had been through there and absolutely screwed that completely up. So you can see there we're getting a much better receive. Let's take it down. See how far we can hear it down. We're still hearing it at 0.1 of a microvolt, so that's pretty good. And let's give it that, what was it, 1 microvolt we had before, and it was sounding really strangled, wasn't it? Now listen to that at 1 microvolt. That sounds loads better. Remember how bad it sounded? Wind the tape back if you want to, video back if you want to hear it. So yeah, that's what somebody not knowing what they're doing is can do to the radios. Let's just turn that down. Yeah, that makes a massive difference. It makes the set usable, you know. It's the difference between it being usable and being completely unusable, particularly for sort of DX work and stuff, which, you know, some of these base stations might be used for. So let's set up the meter for receive then. Although, like I say, the label on the front of it is a little bit worn, but I'm sure you could actually get that replaced, take that out and take it apart and put a new one in, but I shan't be doing that. If you need to adjust the meter, it's RV2 there, shown in your picture. As you can see on here, we're absolutely pretty much as makes no difference on the 9, but I shall just twiddle RV2, just so you can see that move. There we go, there's RV2. We'll bring it absolutely smack bang on the 9. And that's our meter adjusted. And then we just got squelch to do. Not the most exciting thing. We'll just see how we can get that to work on this. They're not the best squelches on these boards, but they're certainly not the worst. Squelch adjustment is just there by the transformer, the choke, just there, and we've set it for 100 microvolts. Yeah, so I've got about the best compromise here. We've got the squelch on minimum, and we're rolling it up to 0.2, and it comes in at 0.2. And it goes off 0.1. So that's on the sensitive side. On the high end, 100 microvolts, it's about 3/4 squelch. So if you wind the squelch dial fully up, you'll get it. Wind it a little back, and you'll bring your 100 microvolts in. That's as good a compromise I can do. I know from experience with these that people definitely prefer the sensitivity on the low end, you know, because you just don't have so many people, you know, that you need to whack the squelch up fully for these days. So the sensitive side is definitely the compromise that I always make. Right, I've just had a look at this for the switch. This rear switch is not switching mains. This front switch is switching the mains. This is switching the mains to the transformer. Now you can pause this if you want. I'm not going to do a version on the computer for this, but that's basically how it's connected up. It's fairly straightforward. You got your socket at the back there, so if you're running it off of your socket at the back, your DC signal comes in. It's got 0 volts there. Your signal comes in, it goes into that terminal block there, it goes through the front, one of the poles of the front switch, it goes round into that terminal block there, goes down, and then dependent on where your rear switch is, it'll either get its power off the board or off of your external supply. If your switch is in that position, then it goes off to the CB there. If your switch is in the other position, basically you're getting your feed off of the external board. The other pole of this switch is all cobbled together. It's just basically a tapping point. There's a capacitor off there, there's the diode off of there. I'll show you on the back side of this switch. So if you've got one of these radios where somebody has ripped all of this out, that is the switching arrangement. Now the rating of this switch is actually 5 amp DC, 40 amp AC, but it's a bit over the top, a 5 amp switch for that. You don't need a 5 amp switch for that. I mean, the switch just needed to be mechanically better, but you could get away probably with a smaller switch, and there's certainly no mains going through that, as I thought earlier on. So, but that is how it's switched. So if you've got one of these, I've shown these how the terminals are inside, okay, with the fuse, and that's exactly how it is there. The rear of the case there are your terminals. So if you wanted to pause that, if you need to wire to it, that's how it's wired, okay? I know it's a bit scrappy, it's just my writing, but if you've got any questions, leave them in the comments. So I've ordered a nice Nikon capacitor for that. The original is a 35 volt one. I'm going to keep it at 35 volts as well, because it's literally half the price of the 63 volt one, so that's fine. So we're going to change that capacitor. That won't be here till Saturday. I'll need to take that board out to change those two capacitors. I'm not going to change any of the other capacitors in the set because, as you all know by now, it's actually working fine. I will give the switches a bit of a switch clean if they need it, but they're moving nicely, so I can't see why they would need anything doing. And the channel selector switch is good. We've got no missing digits, so you don't want to go cleaning switches that don't need cleaning. I mean, this speaker from this side anyway doesn't look that it's got any puncture holes in it. It looks in pretty good nick, and it certainly sounds okay. But that's how the speaker is held in. If you've got one of these without a speaker, that's kind of how it's held in. This, I haven't even checked to see if this transformer is working yet. I should have done that before I ordered things, but I'm presuming it's okay. Very rarely do these transformers go, but I will test that in a minute just to make sure we're getting our voltage off the transformer. Be very, very careful if you're not used to mains when you're doing this. You can get a nasty whack off of that capacitor for a start. Although it's not mains, you can get a hell of a belt off of that. And obviously, even though these are shielded, just be very careful when you're running this on mains. Make sure you're using an RCD protected supply. If you haven't got one in your main consumer board, just buy one of those plug-in RCD units when you're working on CBs. Honestly, it's literally could save your life. So when you're working on gear, I mean, sometimes you do have to work with it with the lid off, with it powered up on mains, and you can do that. But please be very, very careful. And certainly there's no mains involved in that switch, so you're okay touching all those connections on there. Right, what should we do now? We've established how that works. We've still got the socket. You can get the leads for these, by the way. There's a guy on eBay selling the leads for that connector. And I don't know if he's still doing it. I was selling the other version of the Amstrad connectors. I haven't printed any for a while, but Richard mentioned it on the video the other day, so I might well run a few of them off again. I sold loads of those years ago because people seem to find them useful. So there we go. That is it. That's very simple. So that makes my choice of switch much better. Just needs to be rated at DC rated of about 3 amps. I think will be fine. And you could even get away with a single pole switch. You don't need a double pole switch, because as you can see, that other side of that switch isn't doing anything. It's just literally a tapping point for the wires. So if you've got another way of making those wires off in there by joining them together, you could do that and just use a single pole switch. Right, I've ordered some slide switches, which are the right physical fixing holes, so it should be a straight swap. And what I'm going to do is, like I say, that I'm going to double up the contacts on the switch to improve the rating of the switch. And those wires there I'm just going to join into a sleeve and just leave them in a sleeve joined up, because it seems rather a waste of the capacity of the switch. If you were putting a double pole double throw switch in there, we should use both sides of the switch in that. So what I need to do now is just check to see what voltage this, just to check and make sure this runs off the mains. So I'm just going to pop the mains on. I've got no reason to believe it hasn't. It does have a 630 milliamp fuse in there, which looks about right. So we'll just check to see what voltage it's doing, and then when the new capacitor comes, I think it's coming Saturday, we'll do all the rest of the work on Saturday, which means you'll probably see the other half of this video Monday or Tuesday. So we're now powered on with mains, and we'll just go to the positive terminal on there, and we've got 13.8 volts. So it's all working on the mains, so that transformer is okay. No problems there at all. What I'm going to do is I am going to do a TX test just to see how badly that drops, just to make sure the regulator is okay. So what we'll do is we'll put a crocodile lead in there, link that out, and then just test to make sure that this is not going to hum too much or be overloaded on TX. We'll just do a quick test now. That way we know we're not wasting our money putting this capacitor in and doing the rest of the work. Okay, so we're clipped up, we're bypassed. This is rather strange. We've got our DC 13.8 on TX. Actually the voltage is jumping up. You see that? 14.67 volts. So, I would say it's probably that capacitor causing that problem. It's not regulating the voltage correctly there at all. It might be the capacitors on that board as well. So it's good to check this type of thing before you do the work. It is man enough. It is doing the job. and I can't hear any buzzing or anything. We'll just check that actually with the Randy just to see if we've got any buzzing on, but you'll see there the regulation, it's not regulating correctly. 1 2 1 2. There you go, and we've got no buzzing. 1 2. No buzzing, no physical buzzing from this, which is great. But yeah, we've not got very good regulation on there at all. So hopefully with the new capacitors on that board and the new big boy Nikon, which we're going to drop in there, we'll get some proper regulation going on. And we'll have a new switch in the back, and this will all be absolutely hunky-dory. The end user has said that he wanted to have the facility to be able to run it off of mains, which is a nice feature. And a lot of these 407s, unfortunately, that switch does break. I think it's kind of like a Bakelite, not a Bakelite, but it's a brittle plastic, and over the years it breaks easy. So what I'll do is I'll leave a link in the description of the switches that I've used if you've got this problem, and then I think I probably will, because I'm an electrical engineer for my day job, I should really do a better job of the little wiring diagram there. So if you've got one of these and you want to know how to rewire it, or if they're very often missing the transformer as well. I mean, if it's missing the regulator board and the transformer, I don't really think it's worth doing. But sometimes, you know, if you've got most of the components and someone's just cut it out because this switch has blown, they've just linked it out, it's well worth doing, because it makes them more sellable as well if you're selling them on, if you're doing them up, the fact that you can operate it off of as a base station, and also off of a battery, an external battery or an external supply. And I do like these radios. I think it should have a little Harvard sticker going along the bottom of it, and like I say, they did do a version with a silver grill. Now I know there is an eBay seller that does sell these silver grills, exactly the right size to go in here, because this one has been hammered a little bit, but you know, it doesn't really matter, does it? This radio is working very well indeed, and that's really what counts, isn't it? So yes, I think the next video will have to be in a few days once these parts have arrived, and we'll finish this off with a test with Mick and send it back to the customer.
Hey guys, massive thanks for hanging around to watch this first episode on the Harvard H407. Be sure and check back next week for the update on this cracking old radio. We'll catch you later, and don't forget to like and subscribe to Nuxie Man.